Hi everyone, so in this video we'll talk about some properties in operation within events. So we start with the commutative and associative law, and then we talk about De Morgan, and finally the distributive law. So let's start with the commutative and associative. So for commutative law, here it means the order doesn't matter. It's same thing as we do in addition. So 2 plus 3, we know it's same thing as 3 plus 2. Here we apply it on the union and intersection. So A union B is same thing as B union A, and A inter B is same thing as B inter A. Now for the associative law, here it's not about just the order, but it's about grouping. So if you do the same operation like A union B union C, here how we group the events doesn't matter. I can put the brackets with to group A with B, as I can do it with B and C. It doesn't matter. So A union B between brackets union C is the same thing as A union B union C, where B and C are in the brackets. Same thing with the intersection. So A inter B in brackets inter C is A inter B inter C in brackets. So the same thing. This is the associative. Now let's talk about the De Morgan law. So with De Morgan law we have two situations, two law. The first is the first law says that the complement of the union like this, A union B, its complement is simply the intersection of the complement. So I take the complement of this, which is A bar, I take the complement of B, which is B bar, and I inverse the sign here. So instead of union, I take the intersection. Now let's see how we got this. Here we have two events, A and B. A is 1 and 2, and B is 2 and 4. So what is A union B? A union B, we know it's anything in A and anything in B together. So A happens, B happens, and A and B together. So 1, 2, and 4 here in our example. So the complement of this is everything, all possible outcome, which is omega, minus the union. So we get 3. This is the complement of the union of A union B. Now let's check it well. So when we say A union B, means it is either in A alone, or in B alone, or in A and B together. So the opposite of this, the complement of this, is simply it's neither in A nor in B. So it is neither in A, it's not in A, it's not in B also, and it's not at the same time. So and it's not in B. So we can write this complement as this simply. So we can check it. What we don't have in A here? We don't have in A 4 and 3 in this example. We don't have, because A contain 1 and 2, so 3 and 4 are not in A. And what we don't have in B, B bar. What we don't have in B, so we don't have 1, we don't have 3. Because B is 2 and 4, B bar is what we don't have in B, so B bar is 1 and 3. A bar is 4 and 3. The intersection is 3, which is exactly the complement of A union B, because A union B is this and its complement is 3. Now let's see the second law. The second law says that the complement the complement of the intersection A inter B, its complement is the union of the complements. So it is A union A bar union B bar. So what we do here, we take the complement of each one and we reverse this sign. So it is the complement of A union the complement of B. So let's explain how we got this. So we start from here. So A bar union B bar, that means it's not in A, or it's in A bar, that means it's not in A. So not in A, it can be 4, it can be 3, this and this, or it's not in B plus, it's not in B, which means it's 1 and 3. And as we can see, 1 and 3 and 4, it is our omega minus this one to represents actually A inter B, and that's exactly the complement of A inter B. We know that A inter B, the complement of A inter B is simply omega minus the intersection between A and B. So this is how we got this formula. Now we have these two nice law, De Morgan law. The first is this, and this is the second. So the complement of union is the intersection of the complements. The complement of intersection is the union of the complements. In the next video we talk about the distributive law. Thank you for watching.